Welcome to our discussion on how to convert back and forth between the metric system and the US Customary System. The big conversion factor, the one that is, as it says there, the exact legal definition of an inch, is that it's 2.54 centimeters. And that is the one and only bridge that we need to convert back and forth between our two systems for all lengths, areas, and volumes, because everything can be converted into inches on our side and everything can be converted to centimeters on the metric side. The only thing we need in addition to this is 2.2 pounds per kilogram for weight, and then the somewhat lengthy but not too bad conversion between Fahrenheit and Celsius, and then we can convert everything. So yes, you can memorize all these other conversions between feet and centimeters and yards and meters and miles and kilometers and blah, 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 blah. Or you can just memorize 2.54 centimeters per inch, always use the conversion line technique, and convert anything you want to anything else. So for instance, if we want to go yards to meters, rather than having all of this memorized, we can simply go, okay, 4.3 yards, right? We're going to convert this using our conversion line technique, where each space is one of those unity fractions where it equals 1. We know 1 yard is 3 feet. We know 1 foot is 12 inches. Now the feet have canceled out, the yards have canceled out, and we multiply this all through and we'll have inches. Then we know 1 inch is 2.54 centimeters, right? And then we know there's 100 centimeters in 1 meter, and that's going to give us our final answer. You do 4.3 times 3 times 12 times 2.54, divide that by 100, and you're going to get this same exact number without having to have, 400 different things in a table to memorize. You just have to know the things that you already know. You already know feet and yards, inches and feet, right? You should be fairly familiar with the metric system because it's all just powers of 10. And then really all you need is this one unity fraction and you're good to go. So convert 2.5 inches to millimeters. Well, you can do the 2.5 inches times the centimeters, right, to inches, and then millimeters to centimeters, and then there's your conversion. So you can see in this case, we're using that same bridge of the inches to centimeters bridge. All right, how about dual dimensioning? Some companies involved in international trade have to use dual dimensioning on their technical drawings so that the rest of the world will look at the metric stuff and the US people will look at the US standard stuff. So you'll see things with 2 measurements on there. It'll be 83 plus or minus 1 millimeter, or 3.27 plus or minus 0.004 of an inch, and so on and so forth. It really, they say notice that the metric is on top and the US is on the bottom. I don't know if that's standard. I would hope that it would be, since the vast majority of people use metric. I mean, we are literally the only major country in the world that is still stuck on the US standard. It used to be called the British standard, but then they went metric, so it left just us behind, and I think there's like one small country, I think in Africa and like Yemen or something, that are still on the standard, but it's basically just us. Okay, we've got some more things that you could memorize or whatever, but you'll notice that these are little squiggly lines. They're telling you 1 ounce is approximately 28.35, approximately These are not perfect conversions, but you can always get a perfect conversion by using the inch to centimeter conversion, because like I said, all of these things other than weights can be converted using inches and centimeters. So when it comes to weight, we have to rely on these because it's the only bridge we have. The abbreviation for a ton is a capital T. It's the same as the abbreviation for a tablespoon, unfortunately. And the abbreviation for a metric ton is a lowercase t, which is the same abbreviation for a teaspoon. So you would think that would there be problems, but usually the context of the question should make it fairly clear which one you're dealing with. You know, obviously, if you're baking something and it calls for a half of a little tea, you're not going to do a half a ton of sugar, right? It's going to be half a teaspoon, and so on and so forth. So usually the context makes it pretty obvious which one you're using. Okay, converting 75 grams to ounces, we can use the conversion factor that 1 ounce is 28.35 grams. So here's our starting point. Here's our unity fraction. The grams cancel out. It transfers it to ounces. We round to the appropriate amount because we only had 2 significant digits to start with, so we should only have 2 significant digits to end with, so 2.6 ounces. And then we can do the same thing with tons to kilograms, knowing that there's 907.2 kilograms in a ton and blah, 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 blah. Okay. Again, 3 significant digits because remember, zeros are significant if they're to the right of a decimal. And here, 3 significant digits because zeros are not significant if they're at the end of a whole number. Convert 0.075 pounds to grams. Same thing, rounding the same thing. I'm not going to waste time with it. If you want, you can pause and look at it. All right, area conversions. Here are some of the standard area conversions, right? Square inches to square centimeters and so on and so forth. But again, rather than getting approximations, you could always use the inch to centimeters. I know it kind of sucks if you're going to go from like square miles to square kilometers. You got to take a mile all the way down to an inch, take an inch over to a centimeter, and then take a centimeter all the way up to kilometers. But it is one way of getting a precise answer rather than an approximation. So here's 15 square feet to square meters, something like that. You know, I would think is good enough that we could use our bridge, and we could start with 15 square feet. Okay, and we have 1 square foot equals 144 square inches, right? Because that's just 12 times 12. I mean, if you didn't know that, you could do 12 inches over a foot, 12 inches over a foot, and then feet times feet or feet squared, those would cancel that way. Then we've got 1 inch squared equals 2.54 squared, right? Centimeters squared. You could stick 2.54 in your calculator and square it and figure out what this number is. Now we're on centimeters squared. And we want to go to square meters, right? So there are 100 centimeters in 1 meter. And we have to do that twice so that we get, you know, the square centimeters canceling the square meters. And now we're in square meters, right? So 15 times 144 times 2.54 times 2.54 again, divide by 100, divide by 100, and we get something around there. Okay. Hectares to acres, well, you could do the hectare conversion that goes down to square meters and then take square meters down to square centimeters, take those over to inches, inches up to feet, feet up to miles, and then miles up to acres. Or you could use the conversion factor and, you know, get something that's close enough. Volumes and capacities, right? Cubic inch is roughly this many cubic centimeters, cubic yard, a teaspoon to milliliters, and so on and so forth. Do you have to memorize all these? No. Should you have them all on a table? Probably. You could probably get away with just some of the more common ones like gallons to liters, ounces to milliliters, and probably maybe cubic inches to cubic centimeters. But even that, all you've got is, you know, 1 inch is 2.54. So all you got to do is take 2.54 and cube it, and then you have that conversion. So you don't even need that one. So just something to think about. Here's another typical example of going from gallons to liters. They tell us a gallon is roughly 3.785 liters, almost 4, right, if you're trying to do rough approximations in like a grocery store or something. Do the math. Round back down to the right number of significant digits, and you're good to go. Milliliters to ounces, same thing, rounding down. Okay, speed. Well, speed for us is miles per hour or feet per second. In the metric system, it's going to be kilometers per hour or centimeters per second or sometimes meters per second. Just depends on how fast something is. So we can do feet per second to meters per minute. So we do 2.4 feet in per, remember, means divided by, so over 1 second. Then we can do 30.48 centimeters in 1 foot. This is basically, you just took 2.54 and multiplied it by 12. So really we could have done that in 2 steps. We could have done 1 foot to 12 inches, right? And then we could have done 1 inch to 2.54 centimeters. Then we would have had it in centimeters. Then we could do the 1 meter over 100 centimeters to get it into meters. And then finally, the last thing is the 60 seconds and 1 minute. Multiply the tops, divide by the bottoms, and we get roughly 44 meters per minute. So it doesn't matter if we're converting a linear measurement, like feet, meters, grams, pounds, or if we're converting a square measurement, like square feet, square meters, square miles, square inches, a cubic measurement, cubic inches, cubic centimeters, or a compound measurement, miles per hour, feet per second, liters per minute. We still use the same technique of our nice little simple conversion line and our little unity fractions to convert all of our measurements into what they need to be, right? We start with what we have and we end with what we want. It's a simple process that we can do over and over and over again. Okay, temperature is a little bit different, right? On the Fahrenheit scale, water boils at 212 and freezes at 32, which makes no sense whatsoever. On the metric system, however, it freezes at 0 and boils at 100, which makes far more sense. So if you look at the two scales, they have this weird, they don't match up at all. There's not a simple, easy, linear thing. It's not like you can say, 2.54 centimeters per inch. You have a bit of a difference that you have to come up with a bit of an algebraic expression to show the two. Now, of course, you can do a rough approximation. The rough approximation to convert from one to the other is take your Celsius measurement, double it, and add 30, and that will get you a close approximation. So for instance, if you take 10, double it gives you 20, add 30, and it gets you to 50 Fahrenheit. And if you want to go in the other direction, you take your Fahrenheit, you subtract 30 from it, and then you cut it in half, and that will give you a close approximation. Of course, it's only a close approximation. If you need to be precise, you need to know the actual conversion between them. So Fahrenheit equals 9/5 Celsius plus 32. So you take the Celsius, you multiply it by 9/5, which you can see is very close to doubling it, right? And then you add 32, which is very close to adding 30. And then if you want to go the other way, right, so this is if you're given Celsius and you need to figure out what Fahrenheit is. But if you're given Fahrenheit and you want to go the other way, well, then we have to solve for Fahrenheit. And it's Fahrenheit minus 32 times 5/9 equals Celsius, right? So you take your Fahrenheit, you subtract 32, you multiply it by 5/9, and that gives you your Celsius. So again, you can see it's very similar to subtracting 30 and then multiplying by a half. So that's where you get the approximations. But those are the actual, real, true conversions. So we've got the size of an automobile tires given as P205 over 55R16. What that means is the sidewall, right, the measure of the thickness of the tire from the inner edge to the outer edge is 205 millimeters. That's what the 205 is. The 55 means that the height of the sidewall is 55% of the width of the tire, how wide the tire is. If you were looking at it from behind, how wide that tire is. So this is 55% of the width. So obviously the width is almost twice as wide as that. And then R16 means that you have a 16-inch space here for the rims. So you would need 16-inch rims to fit those tires. Those are what those numbers mean. So the second number, this whole 55 thing, is called an aspect ratio. And an aspect ratio is just a fancy way of saying a fraction that describes the relationship between two measurements. And we can figure out what that is, what the actual measurement is, using this idea that we've got 205 millimeters, 1 inch is 25.4 millimeters. So then we can get this measurement in inches. And then from there, if we wanted to, we could figure out what the width of the tire is. So we can find 55% of this result. So some number over 8 inches is going to be 55%. So we get 100H equals this. We get H equals 4.444444, right, when we round. So this basically means that the total height of both sidewall sections would be 2 times that. Then we can add 16 inches to it because that's the rim. And then we can figure out that the overall diameter of the tire from top to bottom is almost 25 inches. All right, suppose a patient was given 30 milliliters of a liquid medication twice a day. If they continue this dosage at home, how many tablespoons per day will the patient take? So we obviously need to take 30 milliliters, change it into tablespoons, and then we can figure it out that way. So we've got the 60 milliliters. We know that 1 tablespoon is 15 milliliters roughly. So that gives us 4 tablespoons. It's that simple. All right, just a couple more examples. For the 2016-2017 year, the European Union projected an average wheat yield of 5.83 metric tons per hectare. The U.S. projection for the same time period was 51.3 bushels per acre. And you're like, oh, dear God. Where 1 bushel of wheat weighs approximately 60 pounds. So to compare these metric yields, we'll convert the European projection to U.S. customary units. We know that 1 metric ton is 1,000 kilograms, 1 pound is 0.4536 kilograms, and 1 acre is 0.405 hectares. So to convert 5.83 metric tons per hectare to bushels per acre, we've got to do this. So we've got our tons per hectare. Then we do hectare per acres to get rid of the hectares. Then we do kilograms per ton to get rid of the ton, right? Then we do pounds per kilogram to get rid of the kilograms. And then finally we do pounds per bushel. And now everything is canceled out except for bushels on top and acres on the bottom. So if we multiply all the numbers across the top, divide by all the numbers on the bottom, we're going to get bushels per acre, and we get 86.7 bushels per acre. Ours was 51.3, so you can see that they are projected to have quite a bit more. Okay, density is the amount of mass per unit of volume of a material. So when we talk about the density of steel is 7,850 kilograms per cubic meter, you can see that it's a weight per metric measurement. That's what density is. So this is kg per cum, right? Kilograms per cubic meter. A lot of times it'd just be kg over m with a little 3 above it for meter cubed, but oftentimes they'll do cu for cubed because they can't do an exponent with the typeset with whatever they're presenting this in. Now in the US customary system, we usually express this in pounds per cubic foot. So if we want to figure out what this was, so we go, well, how dense is that compared to something that we know? We'd have to convert it to our stuff. So here's our kilograms per cubic meters. Again, per means divide by. We change into pounds. We change our cubic meters into cubic yards, and then our cubic yards into cubic feet. Everything's now been canceled out except for pounds and cubic feet. Multiply across the top, divide by all the ones on the bottom, and we get roughly 490 pounds per cubic feet. That's our last example. Here's a table that puts all of the conversions back and forth between our two. You'll see that the only ones that have equals, right? These two because it's using inches, and then this one because it's using yards. We could get an equal one for miles and kilometers. We would just need more decimals because of the 2.54 and how many times we have to multiply stuff. We get a lot of decimals. So that's why this is an approximate. Same thing with all of these. We can get accurate ones for all of these, but they require a lot more decimals. So when you use the conversion line technique and you just have all those numbers written out and then you slap them into your calculator, you then get an accurate answer in the calculator and then you round it, right? So you still get an approximate one, but you can get an accurate one, in the calculator. It just depends on how many decimals you need to show. Same thing down here, right? We've got the two ones here that are defined, and then everything else is approximation because of the decimal problems. And that's all I've got for you.